Good morning, ladies and gentlemen. Welcome to the ERCI webinar. And after a longer break due to the STARS project with the several STARS tutorials, this is a real ERCI webinar on innovative solutions in condition-based maintenance in railway. My name is Lutz Hübner, coming from the Cluster Transport, Mobility and Logistics in Berlin and Brandenburg as one of the 16 members of ERCI. First, I will give you a short introduction on ERCI. It's the European Railway Clusters Initiative, founded in 2010, and it is a legal entity based in Brussels since 1 year, since 2022. 16 railway clusters covering 16 European countries. That is not logical because some of we have also clusters from Spain, for instance, 2 clusters from Spain, 3 clusters from Germany, 2 clusters from Turkey, but we have 1 cluster which is covering all the Western Balkan states. So we have a coverage of, for the moment, of 60 European countries. We are in charge of about 2,000 companies. The majority of them are SMEs. For sure, we have also member companies which are mid-caps or bigger companies or big companies. We are also focusing on research organizations, education institutions, incubators, accelerators, startups, and so on. Yeah, our services is at first to support small and medium-sized enterprises in their development, in finding new market opportunities inside the country, inside Europe, and also outside Europe. We support them to bring their innovation into the market. They are innovation-based. Sometimes it needs, or often it needs, some additional funding support to further develop innovative solutions. That is why we are supporting our members to being part in, for instance, European consortia of research and innovation projects. We do something for the visibility of our members, and one good example are the annual ERCI Innovation Awards. We are dealing with innovation topics itself. They become even more important for the development of the future railway system in Europe, for instance, on cybersecurity, on multimodal logistics, on green and sustainable mobility, norming and standardization, and human factors. And for sure, we giving our members the chance to present their solutions. And one of the best proven instrument are the webinars, which are conducting regularly and in the future at least once a month. And our plan is to do it every second Wednesday in the month. So you can reach us via different sources. Visit our website, visit our LinkedIn channel, visit our X account. I have to say, former known as Twitter. You already know what I mean. And that is already the end of the introduction for ERCI. I have a picture of the awarding ceremony of this year's ERCI Innovation Awards. And one of the winners is the best small medium-sized enterprise. It's called Net Automation, and Mr. Rieger, who is presenting next, is still in the middle here of this picture. And Net Automation is a member of our ERCI partner cluster AC Styria. And first I will hand over to my colleague Bernhard to introduce the cluster a bit and hand over then to the presentation. Bernhard.
Thank you, Lutz, for introducing me. I'd like to welcome you from our cluster as well. As you mentioned, my name is Bernhard Mittelbach. I am the cluster manager of rail systems in AC Styria. Styria is the leading mobility cluster in Austria with now 320 cluster members. And partner landscape is, as I mentioned, not just in the rail sector, it's also in the automotive and the aerospace sector, which makes us quite unique. And one of our main focus is also innovation, and we try to push innovations at our partner landscape. And so we're happy that we, or especially Net Automation, won the annual this year the Innovation Award of ERCI. And now I'd like to introduce you the CEO of Net Automation, Mr. Walter Rieger. He will tell us about his innovations in the brake force measurements. So, Mr. Rieger, the stage is yours.
Thank you very much, Bernd. Let me just introduce you the system. Few words to Net Automation. Net Automation itself has been founded in year 2007. And we are pretty much, I would say, about 90% we are doing research and development, especially on innovative products. And this is one of our product is now the four-speed technology, and therefore I would like to share the screen so that I can introduce you the system what we have developed. Hopefully you can see the screen right now. Basically, what we have done over the past years is we have developed an effective brake force measurement system, which allows us to measure the brake force in between the brake disc and the brake pads, or between the wheels and also the blocks, the brake blocks on the train. If we look at the system consists of a measurement trolley. It consists with the measurement trolley. Inside the measurement trolley is located all these thin film sensors. On the thin film sensors, which is shown here on the left-hand side, is a basic module, which is the communication module. I will explain a few more words later on. And on the basic module itself is connected the sensor module. And this is how we more or less transfer all the information wireless via the router. The router is positioned on top of the trolley. And the HMI, so the user interface, is situated directly on a tablet PC. And on the tablet PC, you can run more or less the brake tests, and there you also can generate the necessary reports. So the benefit, the biggest benefit is, of course, we do not have any mechanical manipulation on the complete brake system on a train when we would like to measure the brake force, as I have mentioned it before. So if you look on the right-hand side, there it is shown one foil when it is mounted on the train. So you slide it in between the brake disc and the brake pad. You fix it with two magnets. And the electronic device is also equipped with two magnets in the back. So this one you also can mount directly on the brake disc. So as I have mentioned before, we are able, this is the first system all over the world, which allows us to measure the brake force between the brake pad and the brake disc without using any tools, without removing the brake pads itself, or we even do not even need to open the caliper or the brake cylinder. So the measurement trolley itself can consist up to currently in use 40 measuring points at the same time. So we are not measuring only one axle or one buggy. We are measuring more or less the complete train at once. If it is necessary that we would have to measure on 80 or maybe on 90 points, it really does not matter. We are able to extend the amount of sensors to the requirements of the operators. So it is recommended the measurement process is done by 2 people. Why do we recommend this? One of the biggest reasons is one person, and because of the long distances on the train, it is recommended that one person is sitting inside the train and is operating the brake system. And via the cell phone, for example, they can communicate. The second person is more or less mounting the sensors outside in the field. The measurement process itself for a complete train takes about 2 hours, and this is a very effective time. And so, what is the benefit from this CBM tool? Of course, one of the main focus on our first customer, like OEBB in Austria, was to extend the maintenance intervals through this monitoring of the brake pads and the brake calipers. We do have a fast data collection and troubleshooting, and of course, it is a basis for the CBM maintenance strategy. On the right-hand side, you can see when a person is mounting these sensor foils, all you need to do is pulling back a little bit these brake pads. The sensor foil itself is only has a thickness of about 0.5 millimeters. So pull the brake pad a little bit to the back and slide it in between the brake disc and the brake pad. And as I has mentioned before, you can fix it with 2 magnets to keep it in position. Now let's look inside the measurement trolley. So of course, inside the measurement trolley, there is the operating manual and also the calibration protocol. As I have mentioned before, the tablet PC is also inside the first drawer. On the tablet PC is situated or is located the HMI, the user interface, from where you can run all your tests. And what we also have is to measure the pressure inside the air circuits on the brake system. You are able more or less to compare what pressure do we have, what force on the brake disc. If we look onto the second drawer, and the second and the third up to the 7th drawer is more or less the same equipment inside. So like this trolley is equipped with about 24 measurement foils. And as you can see it here, there is located a wireless charging unit. We more or less, this is also the reason why the basic modules is upside down, located inside the drawer. We are charging all the modules inside the drawers wireless. And this is just because of the reason by plugging in the cable and plugging it out, we have experienced that most of the modules get damaged quite soon. If we look onto the steel foils, as I have mentioned before, the steel foils is about 0.5 millimeters thick, and this was one of the main focus to be below or equal to 0.5 millimeters. We have experienced if the thickness of the foils are up to 0.7 millimeters, you is not easy, or you are almost not able anymore to slide the foils in between the brake pad and the brake disc. The calibration data, so the calibration itself is done in our house. Of course, it is also an invention from our side, because these measurement foils are more or less not existing all over the world, and because of the fact that we have invented it here in our house, we also had to invent the calibration process. The calibration data is stored directly on the electronic device, which is connected onto the basic module. The reason for that is this allows us to change also the sensors to different types which are used outside in the field. This sensor, what we have shown here, is the sensor for the block breaks. The sensor thickness of these block break sensors is up to approximately 4 millimeters. There we do not have this big challenge that we have to be down at 0.5 millimeters because the block brakes do have much more gap in between the wheel and the brake pad itself. The calibration data is, of course, also stored directly on the electronic device, which is connected to the basic module. And it is also combinable with disc brakes in the measurement trolley. So let's go through a measurement process. In the first step, you have to install all the measurement sensors. So what you have to do is that you take out all the sensors from the drawers inside the trolley. You bring them to the calipers under the train, and you more or less move them in between the brake pads and the brake disc and fix them correctly with the magnets. And after that, also position the electronic device directly on the brake disc. After that step, you also may connect the compressed air sensor. It is possible per wagon that we are using up to 3 compressed air sensors. So, and this is to check the interference between the air pressure and the brake force to see how does the system behave if you, for example, increase the air pressure from example 1.6 to 2.0 bar. How does the force on the brake system behave? In comparison, if you more or less go from 0 directly to 2 bar, what force can you have on the system? And there you can see immediately also the difference if you go into the live chart view. So in the next step, if you have installed all the sensors, if you have connected the compressed air sensor, you are going to use the tablet PC where you have the user interface installed. You start a new measurement process, and the system is looking for all the sensors which are around the environment. And after that, you have to scan the positions, which sensor is located on which position. I would like to go back maybe a few foils to show you, like it is shown here on the block brake sensor. On top of the basic device, you can see the QR code, and with the QR code, you are going to define the position where is sitting the sensor. Is it on the first axle, on the left-hand outer, inner side, and so on. So when you have scanned all the positions, you go into something like a verification mode. It is very important, and this is one of the results of a risk assessment from our customers. We have to ensure before we take the measurement directly, or before we more or less read out the measurement of the brake force of every single caliper, or of every single brake pad, we have to ensure that before we start the measurement process and after we have finished the measurement process, we have to do something like a verification which tells us if we have taken the measurement of every single force, that the system was working properly before and after the measurement. So the next step, verification before the measurement process. Then we go into the measurement process itself. If you go into the measurement process, you also have the option going directly into online live mode, where you can see a chart and you see the behavings of, for example, every single brake pad as it is shown here in the screen. And if I make this a little bit, here you can see, for example, the yellow line is more or less the air pressure inside the brake system, and the lines above is the force of every single brake pad. So when we have released the brake, we have also run a test with, for example, the handbrake. And here is one side of the handbrake. Here is the second one. And as you can see, the air pressure is 0, which means it has been fastened mechanically. If all this is okay, you run into the you go into the measurement cycle. You record all the data of every single brake pad from the train. And after you have done this, you have to go into a verification mode again, as I have mentioned just before, to ensure that the system is still working properly. If this is finalized, you can generate the protocol and you can share all the data which is necessary. Yeah, approvals and standardization, of course, like OEBB was our first customer, was also the trigger why we have more or less developed the system. So OBB is more or less ECM2 approval for the zero mainline. Now we're going to the Talent and Railjets. We are also fulfilling the requirements of the standardizations of the 16185 and the 5215. Is one of the important issues also to fulfill also the requirements of the standards. Our company itself is currently in the accreditation process according to the 17025, which means that we will have also the accreditation, which allows us also doing the calibration on all the sensors according to the 17025 standard. If you talk about the references, this list is growing. Let's say, I would say almost every week, a new customer is more or less be added on the reference list. Here is shown OBB, Stadler, Linz AG, Red, Stadtwerke Bonn, Sternhaferl. So these operators already more or less are using our system, and a few more are outside in the field in the hiring version, as a hiring version. So what is more or less the biggest benefit out of the system, besides the fact that we don't have to do any mechanical manipulation on the system itself? We are focusing very strong onto extending the service intervals. Of course, we are reducing the workloads because the test period, the time what we need for the test run is about 2 hours, as I have mentioned also before. Of course, we increase the vehicle availability because if we would have, for example, to change all the calipers on the brake system, you would have to spend about 2 days with 2 men. And of course, you would also have to organize safe a test drive. In these days, in this case, you also could save these test drives as well. Okay, I also have prepared a short little video which shows the system in operation. So I'm going to share the screen again. So I guess everybody can see the screen. If not, please tell me. So I will comment it a little bit. This is the reason why I have turned off the tone of the video. As you can see here, we bring the measurement trolley directly to the position where we would like to do all the measurements. And the first step, what we have to do, it is not shown here in this video, we have to plug in the measurement trolley onto the power socket. By doing this, every single sensor is switching on automatically. So you turn on more or less also the tablet PC, so the communication link can be established directly via the router. So we are in an island mode. You just take the sensor, bring the basic module into the position, and you move in more or less the sensor directly in between the brake pad and the brake disc. So as I have told you before, you can do this on the complete train, step by step, at once. And as I have said before, you are going to scan every single QR code to define the position of every single sensor. This is what we do right now here in this case. So you scan the position and the system knows now which sensor is situated on which position. What I would like to show here in this case, we are doing also the calibration, as I have mentioned before, in our house. And this is how we also compare with calibrated sensors. We show more or less what is the target value and what is the measured value with the sensor foil. So there we can see quite good what we are measuring directly on the drain. So now I tell the guy, the operator inside the drain, that he should activate the brake. If we go a little bit back, now you see it's activated. And slow but sure, all the measurement values are increasing, and there you can see of every single position what is the force on every single brake pad currently located. So he's releasing the brake. And after that, we could go into something like a live chat. And on the live chat, if you see inside, you can follow more or less every single brake pad. And in this case, it is shown that 2 of the brake pads are not okay. This is, of course, for demonstration purpose here to show that we can analyze which calipers are not working properly. Okay, this was now an overview about the 4-speed system, what we have developed here in our house at Net Automation. If there is any questions, don't hesitate more or less to ask me. I do not share the screen anymore because maybe somebody else would like to share it.
Great. I have a question. It's already there. Do you have patents on your brake force measurements technology?
Yes, so we have patented it. So the technology has been patented it now. Altogether, we are keeping 4 different patents. 3 of them are already published more or less. 1 is still in observation or in the proving process. And yes, this was also one of the main focus from our side when we have done this development.
There are 2 other questions as well. Can the 0.5 millimeter steel foil be used one time or more often before it needs to be replaced?
Yes, of course. So for example, currently it is as follows: the steel foils more or less can be used approximately 1,000 loads. This is approximately 100 measurement cycles. After that, all the measurement faults need to be calibrated again in our house, and then it can be used again for another cycle. So the steel faults can be used several thousand times, I would say.
Mhm. By the way, for listeners, just ask the question directly in the chat, and I come to the next question. Is this a prototype, or is this system already in volume production for, let's say, the ÖBB?
So we have equipped the Austrian railway operators completely. 5 systems in Austria already in operation. All in all over the world in operation approximately now 30 systems. And we do have already contractors more or less situated also all over the world, like in Australia. We are talking also with Japan. Currently, we are in an exhibition in Japan. We have also the contract with Benelux and France. Also going to have a contract now very soon with Denmark and Finland. Excuse me, with Sweden, Denmark and Sweden. Portugal and Spain, we already have the contracts. So Germany, Switzerland, Austria covering, so we are covering by ourselves. And this is also a very important, let me say, experience for us to also be confronted with all the problems on the customer side, so that we also know what is the problems also for our contract partners all over the world.
I see, yeah. Great. So you have no problems with dealing all over the world with different customers.
So let me say it as follows. Let me summarize it as follows. In the first step, we had an idea, and with the idea, we thought, okay, now we can more or less, move on all over the world with this idea. But there was a small little step in between, and this was more or less the development of the product. And the development of the product was very, very consuming times, and also in the time consuming, and also a lot of resources has been consumed in our company just for doing all the development steps, checking all the patents, and also doing the necessary modifications out of the experience we have collected in the past. We have seen after that, when we have finalized more or less also the development, that one of the biggest challenges also is selling the products and going into the open market. And this was very, very difficult. And thanks to ERCI also, we had very, very good feedback also in this stage from this side. And this was also more or less giving us some such a good feedback we could use also on the customer side, and so it was easier for us also to convince the customers about our system. But currently we already do have different contracts already, and we are moving on, and as I have said before, we are joining all the exhibitions wherever we can, and in looking for new contractors.
Great, yeah. So I don't see any more further questions. Lutz, do you have? No?
No, there are no other questions for the moment. For sure, if you have another question, please still use the chat. I'm sure that we will have also after the next presentation some time also to answer questions depending on the first presentation, and that leads me directly to our second presenter. And Petra from Yandex Cluster is already on the screen. And may I ask you to introduce the second presentation?
Yes, hello everyone. Really nice to see so many at the seminars. As you understand, the railway cluster of Sweden, Järnvägsklustret, are also into innovation, and we love innovation and we love business. For that reason, we are proud to present our nominee to the ERCI Innovation Award this year. And besides working with the companies, we have about 40 members within our clusters. We also have a small test facility where you are able to test your sensors, small technical stuff for the railway industry. So we will also invite you to have a look at the Järnvägsklustret in Sweden if you have any questions regarding testing facilities. So enough about that. Now I'm happy to introduce Mr. Peter Melander, who is the project manager and involved with the Railway Metric and Dynamics company. And I think we will have some new ideas what maintenance could be in addition to our local authority, Trafikverket. So please, Peter.
Thank you so much for having me. Can you see my slide?
Yes.
Innovative solutions. What is innovation to you? In the experience of this company, the founders of this company, innovation is best driven out of pain, some sort of pain, self-inflicted pain. In the experience of the founders of this company, is that when you decide to buy 7 locomotives, hundreds of cargo wagons, you sign customer contracts for just-in-time deliveries. You sign contracts with the infrastructure provider that also includes financial penalties. Then, in the middle of the winter, in the middle of the night, your phone starts ringing. Your train drivers are stopped by wayside detectors with wheel flats. The train is 600 meters long, and where is the wheel flat? Of course, you become interested in continuous monitoring and sensor technology, and that's what RMD is all about. Now, in Sweden, we have one infrastructure provider in terms of the Swedish Transport Administration called Trafikverket, and there's some very interesting things going on, and that's what I will describe to you. So my name is Peter Melander. Let me get to the next slide. So for RMD, it's all about digitalization and about monitoring of both rolling stock and infrastructure. And the core business is to develop sensors and sell information about maintenance status and safety status of both aspects, both the rolling stock and the infrastructure, using the same basic sensors. And then, given the history of the company that I just described, real-time monitoring becomes the key aspect. And the purpose of doing that monitoring, of course, is to anticipate and indicate trends, errors, before they become a problem and wake you up in the middle of the night. And the way forward, of course, is then to use this to optimize maintenance of both aspects of the railway system, the vehicles and the infrastructure. It also becomes fundamental to include in this train management system as a train owner, of course. You need to know all about your train, your production, the train configuration. That is also very useful for the sensor systems. So it's all about continuous monitoring for enhanced safety and efficiency. Now, this is the way it then innovations then develop in this beautiful garden. The main flower is the performance monitoring unit that is designed to do wheel flat detection, to do track hunting, track faults, derailment, as in the Gotthard Tunnel, for example, but also rough loading and other operational aspects. Looking at focusing on then what we are doing now with in the innovation tendering with Trafikverket, there's a focus on the PMU and the version of the PMU that we are designing for condition monitoring of the quality of the interaction between the pantograph and the contact wire. And the way to gather all this of course, is to put everything together, and then depending on the user needs, provide different knowledge for the maintenance actors, for the infrastructure manager, and for the train operator, the railway undertaking itself, and preferably presented in a configurable dashboard. Moving on, a dashboard then could, for example, present your 3 different trains that you have in operation right now, and then give you the various aspects of brake percent, whether or not there's dangerous goods or not, on time or not on time. And this starts then building a picture that also can be presented on a map, from the perspective of the train operator, the organizations doing maintenance, the infrastructure manager, and even the train driver, of course. So looking at the core product, the performance monitoring unit, it has 4 super strong magnets for easy installation. It has a super efficient energy source. It contains, in addition to batteries, of course, it contains telematics. To each and every unit has telematics to communicate. And fundamentally, it contains accelerometers. And then, of course, a GNSS, GPS instrument to position. It can be configured either for continuous or event, a sleeping mode, event triggered measurement. And it can also connect to other external sensors for temperature or moisture or smart bolts or so on. And the key, given the background history I mentioned, the key is on things like wheel flats and crush wounds, derailments, but also it's very much based on a deep understanding of vehicle dynamics. So instability, and things like the trend detection that we are developing is very much based on vehicle dynamics and the interaction between the train and the infrastructure. So one new variation of this, together with Trafikverket, is the development of what we call the pantograph sensor system. It's part of the family. It's part of this system of systems. It's basically the same PMU, but based on the frame of the pantograph. Then with wiring connected to additional accelerometers and angle sensor. And again, it has the same communication and telematics capabilities. So this is then the perspective of vehicle monitoring, and as you can understand and see, this on plotted on a map, if you start building an understanding of how the quality of the interaction within the railway system itself between the vehicle and the infrastructure. So each measurement contains the actual dynamic response of the vehicle, both towards the tracks and towards the catenary, the overhead power line, expressed mainly in terms of forces and accelerations. Of course, you also get the position, the speed, and for this purpose, we are developing a lot of our own tools for processing and reviewing the data. And there of course then is in a real-time system like this, there is a great possibility to process the data and highlight different errors, deviations from the normal that needs to be addressed using filtration, statistical analysis, and then of course the visualization, the dashboard. So this again becomes all about continuous monitoring for the purpose of enhanced safety and efficiency. So in the case of infrastructure monitoring, then we need to remember that in Sweden the market is highly deregulated, with one entity, the Swedish Transport Administration, called Trafikverket, that owns and operates the infrastructure, and then dozens of different train companies and train owners and so forth. So what fundamentally Trafikverket wants to do is take a move towards continuous monitoring of the railway system, and especially the infrastructure, using trains in traffic. And continuous, you should see in the perspective of the monitoring that is done today, that is mostly based on inspections, machine inspections using measuring trains, that happens every second or every 6 months, and then of course manual inspections using a manual workforce. So trains in traffic, crowdsourcing, if you will, is the name of the game. The focus initially is on two application areas. One is the track, and the other one is the catenary system. One of the biggest part of this then, of course, becomes instrumenting vehicles, trains in traffic with the right equipment, the PMUs. And then the task becomes to measure track and deviations rather than errors, but to detect deviations from the normal. And then the same for the overhead power lines, the contact wire. And what the way to do this then is to for us to do a pre-analysis of the data that we do, and then deliver this information to Trafikverket for the purpose of decision making, to make the right decisions on activities in the track, maintenance activities in the infrastructure. And then because we are basing this on trains in traffic and this type of crowdsourcing, we are also presenting the breakdown of the infrastructure, or if you will, trends, and providing the possibility to provide suggestions on priorities, given how vehicles are reacting to deviations in the normal condition of the infrastructure. It then becomes valuable to, on a very frequent basis, collect information on how the vehicle reactions are changing over time. So the setup and the configuration for doing this then includes different variations. So one element is to have a PMU that does two things. It provides the dynamic reaction on this level of the in-between level of the vehicle, and that becomes especially interesting when you have the two other levels on the bogie frame and on the pantograph. It gives you a very good understanding of the vehicle dynamics in action, in cooperation with the infrastructure. And the other thing is to have a very accurate GNSS positioning and other positioning technologies in that. And then the measuring on the bogie itself is of course very much looking at the track, and in a similar fashion on the pantograph, the focus then of course is on the interaction with the overhead power line. And then there's the more of the vehicle targeted configuration that we already have hundreds of on hundreds of freight wagons in operation today. So so it's all about the quality the technical quality of the technical cooperation, if you will, in the technical system, the technical interface between the vehicle and the infrastructure. So it's based on vehicle responses that then of course varies depending on what sort of deviation you have from the normal in terms of condition. And of course, the vehicle type, the vehicle speed, the weight, all these things that we get from the train management system is a part of the measurement. And in a step-by-step approach, we move from simulations to machine learning, and in all of this, the complete picture that we have includes then the characteristics of the vehicle and of the track and so forth. And we have in this setup the possibility to calibrate with actual measured data. So then presented on again in a map sort of format, we then can demonstrate this in different ways, for different sections with different time segments, and compare with other types of information. So what's underdeveloped now is we'd like to, you can call it different things, and in the academic research there are different descriptions of this, but one way to describe it is as a dynamic track force index, that where track includes both the actual rail tracks but also the overhead power lines. And this is where we are now developing the value presented to the infrastructure owner in order to provide a new perspective on understanding the condition. It becomes very important to keep in mind the vehicle dynamics and what actually causes degradation. Trains are heavy. Trains are often a lot more heavy than measuring trains, and the forces implied, it depends on track geometry, the mass of the wagon and the payload itself. And it's also important to remember that the suspension in this, at least in a ballasted track, is divided. There's a lot of suspension in the track bed itself, and also in the vehicle, and that's why measuring condition in the units of millimeters is very well complemented by measurements in units of forces and accelerations. And the way we do it is then, of course, to measure acceleration both on lateral and vertical, on using the bogie frame itself. And the key element for us becomes the vehicle response. How is the vehicle responding in this context of the quality of the technical cooperation between the vehicle and the infrastructure? And quickly moving on, there's many aspects to the interaction between the pantograph and the contact line, but of course, looking at the distance from the track and the track bed to the top of the train, you have a very powerful arm, and moving at high speeds with high mass. There's a drastic impact on the forces and the actual accelerations, and it becomes important to do this sort of crowdsourcing and have trains in traffic that gives you this additional perspective. So finally, so we have signed a contract. We have won a contract with the Swedish Transport Administration that goes in steps. So innovation tendering is.
Peter, I'm sorry, you accidentally muted yourself. Thank you.
Okay. Oops. How I hope you had a pleasant rest. Hope not for too long. So did you hear me say that we have signed a contract with Transport Administration? Okay. And innovation tendering is really all about buying something that almost exists. And that we are developing then in stages. We are now into stage number 2, and given that we meet the minimum criteria, we will then move on to stage 3, which is it's daily business. It's then a continuous service, and then this will of course develop. This initiative of using trains in traffic is a part of a set, an umbrella of developments done by Trafikverket. But the immediate effect, of course, is given that we're looking at both the vehicles and the infrastructure, is that you get an immediate positive effect in terms of efficiency and safety. But because the number of vehicles participating and the number of vehicles being instrumented and the use of machine learning, having access to more and more data to learn from, we are only just seeing the sunrise, and it will get warmer and better for every day, every week, every month. But it is very much about to measure the interaction and the quality of the cooperation between the vehicles and the infrastructure. So that's that. I think I consumed my 20 minutes.
Yes, thank you so much, Peter, for this deep introduction of RMD and your product. We have a lot of questions. I don't know, Lutz, if you have had the time to copy it all into.
Yes, for sure.
Yeah. I think actually we should start with the technical questions now when we into it. So, Peter, can you in any way qualify the PMU as a kind of an IoT device, or how does that work?
It is an IoT device. I mentioned briefly calibration, and because of this fantastic cooperation with Trafikverket in this specific case, we do have access to a lot of data. It is a joint innovation activity, and that's one way of going about the qualification. I hope that answers the the question.
Yeah, otherwise we will have more comments in the chat, I hope.
Yes. And
Moving
there's
on.
also my email.
Yes, of course. Then who is doing the smart analytics, transforming the data into valuable information? And who in person decides if the train has to do a maintenance stop or out of schedule in order to avoid a breakdown?
Right. So that's a question focused on the train rather than the infrastructure. And I would say in both cases, we within the company are developing the algorithms, the analysis, and then it becomes a question of setting thresholds, if you like, and that is done then in cooperation with the owner of the asset. And that creates the foundation for the decision-making process.
Yeah, but yeah, and then I understand your system and the data and the information that you can provide can then be managed to the different internal processes that the customers has decided.
Correct.
Good, thank you. This is a comment. You said that you can avoid the regular testing. However, it seems that you can only detect faults when it's already large. So how large are your reliable detection threshold compared with the testing?
Well, if I answer that question in relation to the infrastructure rather than the vehicle, it's important to state that at no point did I want to say that this type of vehicle dynamic perspective on condition monitoring is to replace anything. Quite the contrary, it's very much an addition. It's to be seen as a additional perspective. So it's a complementary to it's an add-on to other inspection techniques that are already working and in place. And what was the second part of the question? Of the comment?
How large are your reliable detection threshold?
Well, as it is to be used as a additional perspective, at least in terms of the infrastructure, the thresholds are based and used in cooperation with the thresholds used with measuring trains technologies. So again, it becomes an additional perspective used in the decision-making process on deciding on maintenance actions, what action, where and when, and so forth.
Yeah, you still need to have people and other solutions, but maybe you can have more decision based on when and who are going to be at a specific spot in a specific time to save life and money.
Yes.
I think we're going to the next speaker soon, but I just need to ask you, are you looking for any kind of collaboration with other partners in Europe for the moment?
Absolutely. This is a great opportunity for collaboration, as we are addressing this system view, and also within Trafikverket, this is under the umbrella of many things going on with creating digital twins, the ever popular topic, having other wavelength and technologies to inspect and so forth. So yes, this is all about cooperation.
Yeah. So you will have many emails after this session.
Thank you.
So over to you, Lutz.
Yeah, I have another question for Walter. Is there a difference in measuring brake forces in freight and passenger trains, which is the return of experience from freight trains? No. Walter, can you hear me? Are you still on the line?
Unfortunately, Walter is at the moment not available, so I will forward the question to him.
Yeah,
Could you
the
please
question
mention
will-
where the question came from, that I
Yeah.
could forward it him?
Yeah, that is no issue. The question, the source of question is known, well known. So I would then go to our short request to all of you to fill in a short feedback questionnaire on this webinar. It's on how is the quality of the presentation, the quality of the organization, and so on. And maybe also you have some tips for us for further topics to be addressed in future ERCI webinars. You are very welcome to do so by filling in this questionnaire. So then I have to hand over to Veronica Bocci. She is the coordinator of the LINA 2030 project. It's on resilient supply chains for raw materials for the railway sector. Veronica is Vice President of the European Railway Clusters Initiative, and we will give you the chance to say some words about the very first ERCI funding project. Veronica.
Thank you very much, Luther, and good morning, everyone. I take the opportunity of your presence here to promote the first concrete action of this Europe's Rail project that is somehow not very fundamental for the entire European rail supply industry, because it has to do with, with disruptions in the European rail value chain, having to do with materials and components, not only with the state-of-the-art standard products and solutions, but rather with the innovations. And as we are here today also to speak about innovations for the railway sector, you know how much it is important to ensure that your ideas and your innovations can actually reach the market. And this based on the fact that you can easily source the materials, the components, the assemblies, and so on that you need to pack your solutions. So let me just frame a bit better why it is a real problem for our sector. Our sector is leader globally, and we want to remain like that. But in order to remain like that, we need to have a clear ideas about how to ensure our autonomy and reduce vulnerabilities in the supply chain. And let me start reminding the famous economist Milton Friedman that many decades ago, when trying to explain how the market price was, the price market, was working, he made the example of a pencil. And also in such an easy product like a pencil, is composed by components coming from countries, okay? Graphite from Mexico and Brazil, wood from Sweden and South Africa, aluminium from China and Mozambique, rubber from Thailand, Malaysia, and lacquer from Kazakhstan and Estonia. And we are speaking about a pencil. So imagine how hard it is, okay, for all the components, all the products of the railway sector to deal with this in periods like the ones we are living. For this reason, Europe's Rail launched last year a call named European Value Chains for Rail Supply, aiming to ensure and to clarify what will be the supply chain needs for the future once you are struggling and doing the best to develop innovations for the railway sector. To know what will be the supply constraints, to make a risk analysis of supply availabilities, okay, for the innovations that Europe's rail program is delivering to the market, and to identify what are the strategic options to ensure resilient solutions, your solutions to be resilient and to remain autonomy as European industry. So the framework is complex, okay? We have experienced the disruptions led by COVID, and then by the war in Ukraine, and then by logistics, closed ports in China, and so on and so forth. But the question about if we will have enough material components also depend on other aspects. And other aspects have to do with the fact that, for instance, for batteries, we are competing with other sectors, and the components necessary to manufacture and produce batteries are not enough, first of all, and then come from countries so far away, and also threatened, let me say, by geopolitical aspects and also by climate change aspects. And then also the framework is becoming even more complex because of the new EU directive on sustainable due diligence that will push many OEMs to revise their supply chains to ensure that their suppliers are respecting sustainable principles, and so on and so forth. So the framework is complex, and we need to know, okay, how we are addressing this this huge challenge. As ERCI, we are representing, as well explained by Lutz, the rail supply industry in 16 European countries. So we are on the territories. We have you industries as members, and we want to know from you what happened to you, what you experienced, or what you are still experiencing, because we need to know from the state of the art to best predict what can happen when you will deal with innovations in the coming years. We are doing that with the French Rail Research Center Railenium, with the JKZ in Germany, that is the value chain of the mines, okay, the raw materials value chain, and with the Technopark Istanbul, that can help us understand how other sectors, very technological ones, defense, aerospace, and so on, are addressing the same challenges like you are doing. So for this, we will deliver a set of activities, but today I'm just asking your attention on the first. We are now in the phase to study the past to identify alerts for the future. And for this reason, we have launched a European consultation on the disruptions and the dependencies experienced by suppliers of any size, and SMEs and startups are absolutely important because you are the majority of the railway industries in Europe. Okay, so we need to know from you also because your companies in the majority still don't have, let me say, resilience plans and can be more affected by disruptions in the supply chain. But also we need the larger companies, okay, and the infrastructure managers, the railway undertakings to answer, because they source a lot and they, in proportion, surely had many disruptions. To reach out to the most of you, we launched this time the consultation not only in English language, but multi-language. Today, we have already launched in 5 languages: English, German, Spanish, French, and Italian. And we are going to launch in a few days also in Polish, Swedish, Serbian, and Turkey. Why in Turkish? Sorry. Why this? Because these are the languages of the 16 railway clusters in ERCI. Maximum confidentiality of data. This absolutely we ensure. So feel free to answer our questions. Share with us all your knowledge, because you will help us and we will help you to know more and be more resilient. Also, be sure that the results will be packed, anonymized, and aggregated, so no one will know what exactly your answers were. So please contribute. This is very important. So thank you for your attention, and all the best.
Thank you very much, Veronica. For sure, whether you have questions, you have still the possibility to raise a question into the chat or to raise your hand. For sure, there are also participants from other countries here, not covered with the languages. For sure, they are free to answer the English version of the questionnaire. And to get some more information on the LEADER 2030 project, I put you the chat from the project website in the chat, and also all these 5 available, already available consultations in these 5 different languages. The links are also already in the chat. There was one finger raised, but I'm not sure who it was. Maybe you can only open your micro and answer and raise your question. Maybe it was a mismatch of of one of these buttons here available in Teams. For sure, you can raise your questions anytime. You have also our contact data, and you can go directly to ERCI to receive some further information on these presentations here and on these LEADER 2030 project. For sure, you could also use the feedback questionnaire to raise further questions if it is necessary. So I wanted to share my screen again, not to forget it, to show you that we have 2 other initiatives currently running in the ERCI universum. The first is the Success project that is already running since months, and it is to support the European SMEs of the rail supply industry in successfully applying to public procurements in the USA, Canada, and Norway. That means all outside Europe, Norway outside the European Union for sure. The link to that project is already in the chat. And for the moment, the Success project is providing Tending Watch newsletters for the moment for the USA and for Norway, in the near future also for Canada. If you are interested to receive these Tenders Watch newsletters, I kindly ask you, or we kindly ask you, to contact directly these 3 persons, Ms. Irina Vesco from DTEC Fair for the USA, Ms. Oyan de la Rua from MAFEX for the Norway Tenders Watch newsletter, and you can already contact Ms. Amélie Esperou from eTrolls. She will manage the launching of the Canada Tenders Watch newsletter in a few months. So then I have another thing for you. Maybe you already know it, and it is still online. The STARS project has been finished on 30th September 2023, but the B2B matchmaking platform is still open. and it will provide some time slots for immediately meeting after the webinar. It is possible until 18 o'clock in the evening. The only precondition is that you must have a profile, a short profile on this platform, and it is easy to install. And the main focus of this website is matching companies in the rail supply industry with solution providers that might support them in adopting advanced technologies to improve products, services, manufacturing processes, and organization. And yeah, that is the main target. If you have some other problems, yeah, you can be free to discuss with your participants also other participants also other things, but the main target is that what I mentioned. So I look into the chat and see that there is no other question for the moment. Please correct me if I'm wrong. Then I would show the last page. No, that is not the last one. That is the page for the recording of ERCI webinars. Each ERCI webinar will be recorded, and due to the STARS project, there is still available a YouTube channel. And after recording, give us 2 or 3 days. Then we try to upload the recording into this STARS YouTube channel, and you can watch this ERCI webinar also afterwards. So last slide is that we will have the next ERCI webinar on 13th of December, not 13th of December. The topic is not yet fixed. If you are in the position to say, oh, that's interesting, maybe also for my company, can I present my innovative solution? Please come to us and propose your presentation. You can also use this our feedback questionnaire to do so, and the link to this feedback questionnaire already put again into the chat. Please use it, and if there are no other questions for the moment, we are at the end of this ERCI webinar punctually. Thank you very much for your attendance. There is one question. Can you open your micro and put your question, please? I saw one hand.
Yeah, no, this is just to tell you that thank you for this good session. Yeah.
Yeah, thank you. Yeah, thank you very much, and all the best to you. And we will keep you informed. For sure, you will get some additional information material like presentations and so on after the webinar with a separate email. And we would be very pleased if you remain on board for future ERCI webinars. Have a nice day and see you soon. Bye-bye.